This video has the answers to the lesson 7-2 assignment. First, problems from page 295, where we're given proportions and asked to solve them. A proportion is an equation where one ratio is equal to another ratio. In number 1, the first ratio is x over 5. The second ratio is 3/4. Notice the equal symbol in the middle. This kind of equation, in which there's a fraction on both sides of the equal, is called a proportion. A proportion is solved with a theorem that reads, the product of the extremes is equal to the product of the means. The extremes are the numbers on this diagonal. The extremes are the x and the 4. The means are the numbers on this diagonal, the 5 and the 3. The word product in the theorem implies multiplication. Here is the equation that's created by using that theorem. The product of the extremes, that means multiply together the x and the 4. That makes 4x, is equal to the product of the means. That means multiply together the 5 and the 3, which is 15. These are your extremes multiplied together, and the 15 is the result of the means multiplied together. Notice that by applying this theorem, that equation is created that no longer has any fractions, and it is solved like we have all year long. To get the letter x alone, you need to divide both sides by 4, and the result is x equals 15/4. That can be written as a fraction or a mixed number or a decimal. Now, number 3, solve this equation. This equation is called a proportion. I know it's a proportion because of its format. This is a ratio, right? One number compared to another using division. And this is a ratio. An equation that has a ratio on both sides of the equals is called a proportion. So as soon as you recognize it's a proportion, apply the theorem. The product of the extremes, that means to go 8 times the 3x, is equal to the product of the means. That's the 5 times the 4. 8 times 3x is 24x, and 5 times 4 is 20. By applying that theorem, we create an equation that does not have any fractions in it. To get the letter x alone, you divide both sides by 24. Getting x is equal to 20 over 24. That's a reducible fraction. Top and bottom both divide by 4, creating 5 over 6. Or you could give the decimal version of 5 over 6. Number 5, do you recognize that it's a proportion? As soon as you do, the technique is to multiply the extremes. That's the 3n times the 5. And then say equals and multiply the means, the 7 times the 4. This makes 15n is equal to 28. Now solve this equation by dividing both sides by 15. And n is equal to 28 over 15. Or you could give a mixed number for that, 1 and 7/15. Or you could even give a decimal for that. Number 7, this is a proportion. The product of the extremes is equal to the product of the means. 21 is equal to 12a. Now get the letter a alone by dividing by its coefficient. And we get a is equal to 21 over 12. Now this is reducible. Both numbers divide by 3, making 7 over 4. Number 9, you probably have the pattern by now. So the product of one diagonal is equal to the product of the other diagonal. Now, because of the size of these numbers, a calculator would be helpful. 18 times 39 is 702. 13 times 36 is 468. Now what do? To get x alone, you divide by its coefficient. And x is equal to 468 over 702. Now, both numerator and denominator are even numbers. They for sure divide by 2, and it's possible they both divide by something even larger than 2. I'm going to make use of a calculator to automatically reduce the fraction. Use the fraction button, and in the top, put 468, and in the bottom, put 702, and then push enter, and this simplifies to 2/3. Now number 11, the product of the extremes is equal to the product of the means. With a calculator, you can figure out 24 times 7. And with a calculator, 25 times 6. That's 150. Now, how do you get the variable alone? What's the number in front of the variable that needs to be removed? So you divide by the 150. Y is equal to whatever 168 over 150 makes. You can reduce that with the fraction button, or you could just type it in using division, and your calculator will either give you a mixed number or a decimal. I'm going to type this one in using division. 168 divided by 150. That's 1.12. So I chose to give the answer as a decimal here, but I could have given the answer as a mixed number. Now number 23. On the left side of the equals is just the whole number 2. If we put a 1 underneath it, now we've created a proportion. 2 times 7 along the 1 diagonal is equal to 1 times 6 plus 4n along the other diagonal. 2 times 7 is 14, and when you multiply something by 1, you just keep that same thing that you had to begin with. And here is our resulting equation with no fractions in it. Now solve this equation like you've done all year. We want to get the term with the n alone. That requires us to move the plus 6. So take away 6, take away 6. This makes 8 is equal to 4n. Well, now what do? You could mentally say 4 times 2 makes 8, and so you know n has to be 2. Or you can continue with the work steps and say divide by 4, but you're still going to get that n is equal to 2. Now number 25. This is also a proportion. It has the same look as a proportion. It has the equals in the middle, it has a ratio on the left side, and it has a ratio on the right side. So just because you see these polynomials, don't let that stop you. The same method is going to work. Multiply the extremes together. That's the 6 and the 5n minus 3. And that's equal to, now multiply the means together. That's the 4 and the 5n plus 3. Now what do? Do you recognize that the distributive property can be done? 6 times 5n is 30n. 6 times 3 is 18. 4 times 5n is 20n. 4 times 3 is 12. Now we have an equation. It doesn't have any fractions anymore, but it has the variable n on both sides of the equals. We don't want that. We want the letter n to only be on one side. So we could subtract the 20n from both sides. 30n subtract 20n creates 10n. On the right side, now there's only a 12 there. Now we want to get the 10n alone. We have to move the term that's next to the 10n. Underneath the minus 18, add 18. This will create 10n is equal to 30. 10 times 3 is equal to 30. So n has to be equal to 3. Now page 296. These have very short story problems, and we're asked to write a proportion that fits the story and then solve it to answer the question. So I didn't write out the full story problem, that's in your textbook, but the main idea of the story is this. 6 oranges cost 99 cents. Question, how much will 10 oranges cost? You do this by choosing a variable to represent the unknown. I don't know the cost of the 10 oranges. Let's call that x. And then later on, if we figure out a number for x, we will have figured out the cost for 10 oranges. Now, take the given information and create a proportion from it. 6 oranges cost 99 cents. Now say equals, and say 10 oranges costs x. When you write your proportion, you want to make sure your labels match. This is oranges. This one was money. This one was oranges. And this was an amount of money. Notice both of my ratios are in the same order. I chose to put oranges on top and money on the bottom. I could have rearranged it different as long as I keep that same order in my second ratio. Now solve this using our technique with multiplying the diagonals. 6 times x is equal to 0.99 times 10, which is 9.9. Now divide both sides by 6 to get the x alone. 9.9 divided by 6 can be done on a calculator, and it is 1.65. Now, because this is a story problem, we want to make sure we write our answer in a form that communicates our understanding. What was the letter X representing? It was the cost of the 10 oranges. It's an amount of money. So wherever you're going to write your final answer, you want to label it using a dollar sign so that you're communicating that this is an amount of money. Now, number 3, the story is that some person is driving 111 miles in 3 hours. And the question is, how far can she go if she drives for 5 hours? So let's choose the letter X to be how far she can go in the 5 hours. Now we can create our proportion. And when you create your ratios, pay attention to the labels so that you're matching them up appropriately. 111 miles in 3 hours. Then say equals. And in the other ratio, what are we going to write for miles? The X or the 5? The X. And then in the bottom, the 5. This was miles. This one was hours. This one was that unknown amount of miles, and this was hours. Notice that I have miles over top of hours and miles over top of hours. Now we can use our multiplying the diagonals technique to solve this. 111 times by the 5 is equal to 3 times by the x. This is 555 is equal to 3x. Now divide both sides by 3. And we discover that x is equal to 185. Now don't leave it like that. You're doing a story problem. So communicate what you've actually figured out. What was the letter X? It was how far the girl can drive. So we should say it's 185 miles. Okay, now back to the section from the day before, page 289, simplify these ratios. What we discussed in the presentation the other day is if you're given a ratio using the colon symbol, then you should rewrite it as a fraction because now it's just reducing fractions. The largest number that divides into 14 and 21 is 7. They can both be divided by 7. And this makes 2 over 3. The other thing you can do is you can use your calculator's fraction button, put 14 on top, put 21 on bottom, and just push enter. Okay, number 3, write it as a fraction. That's going to help you to do the reducing. 24 divided by 8 makes 3, and 8 divided by 8 makes 1. The letter X in the top, the letter X in the bottom, cancel away completely. The final result is a 3-to-1 ratio. If you want to, you can take the time to rewrite that using the colon, but it's okay to leave it in its fraction form. Now, number 5, s squared compared to 3s squared. We had this in the last chapter. We know that we need to evaluate this denominator piece first. So we have s squared over 3 to the second power is 9, and s to the second power is literally s to the second power. Now, what sort of reducing do you notice? There's an s squared in the top and an s squared in the bottom. Those cancel out, leaving 1. The final answer is 1 over 9. Now, number 21, there's a little story to this, and I didn't write out the whole story, just the key information. What we're asked to do is to write a ratio. And in our ratio, we want to have school days as the first value and non-school days as the second value. And it has to be in that order. We know the school days. There's 180 school days. Now we're asked to compare that to non-school days. Should we put 365 in the bottom? Nope, the 365 is the total number of days in a year. That's not how many non-school days there are. So you have to do a little side calculation here to figure out how many non-school days there are. There's 365 total days in the year. You're required by Michigan law to go to school for 180 days. So do that subtraction and find out how many days you're not in school. It makes 185. So now we can finish our answer. The denominator is 185 non-school days. This is going to simplify. Because one number ends in 0 and the other ends in 5, I know for sure that they both divide by 5 and maybe something even bigger. I'm going to use my calculator's fraction button and type 180 on the top and 185 on the bottom. And this reduces to 36 over 37. Now number 23. There's a little story problem that talks about airplanes, and we're asked to write a ratio of new planes to old planes, and it has to be in that order. The new planes has to be the first number, and the old planes has to be the second number when you write your ratio. Well, we don't know the number of new planes. We know there's 720 planes total, and we know that 240 of them are old. So how many are new? Let's do a calculation to figure this out. 720 subtract 240 leaves how many airplanes that are new? This makes 480 planes. Now we have the information we need for our ratio. There's 480 new airplanes compared to there's 240 old airplanes. Now reduce this. Some of you might recognize just mentally that this reduces to 2 over 1. If you don't recognize that, you certainly can make use of the calculator and reduce it on the calculator. There are 2 new planes for every 1 old plane. This concludes the answers to the assignment.